Oops. Okay, so let me go to the course so you can see what I want to show you here. Just give me 1 second. I got to find. All right. Share screen, Safari. All right. So when you're in our course, you go to materials in Unit 5. There's the stuff for this week. And the week of 12/7 to 12/11, I added well, it's like an assessment, but it's like a homework thing. This Ionic formula naming, or Ionic formula writing and naming. And that you need to do by tomorrow. So here's what I want to do in class today. This writing and naming ionic compounds were some practice problems. And if you happen to do those, like yesterday leading into today, that's great. I want to go over those with you right now. And if they all make sense and you don't have any questions about that, then I'll answer any other questions you have. Then I'll set you free and you can do this ionic formula writing and naming. You have until tomorrow night to get it done, but you can do it like today. In the writing and naming ionic compounds paper, there is some information at the top and a few basic questions about naming and writing basic ionic compounds. These don't include polyatomic ions or transition metals, which we'll do tomorrow and Thursday and Friday. But some basic ideas are, you got to find the charge for the ions that would make up, that those elements would make. And then you can do the cross-down method. If it's, for instance, magnesium and chlorine, magnesium on the periodic table is in group 2. So it has a charge of 2+. Chlorine is a halogen all the way on group 17 on the right-hand side of the periodic table. So it has a charge of 1-. You would need 2 chlorines to go with every magnesium to end up with a neutral compound, or whatever the charge for magnesium is how many chlorines you need. Whatever the charge for chlorine is, that's what you're going to need for the number of magnesiums. So the compound formula ends up to be MgCl2, and it's called magnesium chloride. So the name of the compound is whatever the name of the metal is. That's the first element, and then the non-metal, chlorine. That's the name changes from chlorine to chloride. So there's some questions in here, and I've got this on another page that I can share a little bit differently. Let me switch the share to this thing. All right, so I have those questions on here and with a periodic table, so we can see the questions in the periodic table together. And I know the table's a little bit small, but at least I can point out where the elements are. So number 1 says, why did group 1 and group 17 join together in a 1-to-1 ratio? Well, group 1 is right here, and group 1 has a charge of 1+. Group 17, that's right here, and they have a charge of 1-. So everything in group 1 has a charge of 1+. Everything in group 17 has a charge of 1-. They form a 1-to-1 ratio because any element in this row, like if I pick potassium and chlorine, potassium is K1+, chlorine makes the chloride anion, Cl1-, and you need 1 potassium and 1 chlorine to have a neutral compound. That's KCl. Potassium chloride is the salt that's put into Gatorade and other like sports drinks. Whenever you sweat and you lose a lot of potassium, and potassium is very important for preventing muscle cramping. So really Gatorade is just potassium chloride in water, but potassium chloride tastes terrible. So you have to add sugar and sugar and some kind of flavoring or something to mask the terrible flavor of potassium chloride. So the electrolyte that's in Gatorade is potassium chloride. That's what KCl is. Why did group 2 and group 16 form together in a 1-to-1 ratio? Well, group 2 is right here, and they have a 2+ charge, and group 16 also has a 2- charge. So if you were to pick something like I don't know, magnesium oxide, it's Mg2+ and O2+. And this is the example that's right above. So with the cross-down method, it looks like it would be Mg2C or Mg2O2, but we don't write that because the ratio that you need to have a neutral compound would just be 1:1. It's just MgO. If the subscripts for ionic compounds are both evenly divisible by the same number, here 2 and 2 are both divisible by 2, you just reduce them to the least ratio. And really the only example that you're going to have is whenever there's an element from group 2 and group 16 where it's 2 plus and 2 minus, that's really the only case when the cross-down method doesn't work easily. So use a periodic table to predict the charges. All you do is look at the group number. So magnesium is 1 plus. You can also write +1. Phosphorus is 3 minus. Strontium is 2 plus. Sodium is 1 plus. Bromine is 1 minus. Beryllium is 2 plus. Magnesium is 2 plus. Barium is 2 plus. I can back that up. There we go, 2 plus. Aluminum is over here. So although aluminum is in the D or in the P block, it's the third group over. It has 3 valence electrons, so it's 3 plus. Then selenium is right here, and that's 2 minus. Hydrogen is 1 plus, and then calcium is over here, and that's 2 plus. So those should be what you have. And what's the formula for barium bromide? So barium bromide, you find barium, that's right here. And then you find bromide is from bromine, which is right there. So barium has a charge of 2 plus, and bromine has a charge of 1 minus. So you can do that cross-down method if you want. Barium's going to have 1, and bromine's going to have 2. So it's Ba, Br2. That's D. Okay. Any questions about those? You can ask it, or you can put it in the chat. If you're confused about something, easiest thing to do is if you're confused about something, you want to just put it in the chat. I can see it there. But if you want to turn your mic on, if you have a question, go ahead and ask. Okay, cool. So then the next page, or not the next page, but the next problems, I just have it on a different page here. We're writing a formula for the ionic compound and name the compound. So we have aluminum and sulfur. Whatever the charge for aluminum is, it's the number of sulfurs you need, and vice versa. So it's going to be Al2S3, and that's aluminum sulfide. Sorry, my tablet's a little slow this morning, so it might look a little bit goofy. Calcium and sulfur is just CaS, and that's calcium sulfide. Sulfur changes to sulfide. BeO2, or BeO is just BeO because it's beryllium and oxygen. Each has a charge of 2, so you only need a 1:1 ratio. That's beryllium oxide. Oxygen changes to oxide. Aluminum and fluorine, it's just AlF3, so it's aluminum fluoride. And then strontium and chlorine is, oops, back that up, SrCl2. That's strontium. Some people say strontium, or I don't know. They say strontium sometimes, but usually it's pronounced strontium chloride. And then barium nitride is going to be Ba3N2. And then SrBr1, or Sr2 with Br1, is strontium bromide. It's SrBr2. Strontium bromide. And then LiO2, that's lithium dioxide. So it's going to be Li2O. Lithium oxide, not dioxide. Lithium oxide is an interesting compound. Speaking of space travel, it's actually used in space travel. Whenever you exhale, you breathe out carbon dioxide, and the carbon dioxide concentration can increase in a spaceship. So one way to remove carbon dioxide is to use lithium oxide. So lithium oxide is taken up in these canisters, and the lithium oxide reacts with carbon dioxide and removes the carbon dioxide from the air. So sodium and sulfur is going to be Na2S, sodium sulfide. And then magnesium and bromine and magnesium bromide is going to be MgBr2. Let's see. I guess those look pretty good. I think I got them all right. Yep, they look all right. So that's how that goes. That's good examples for 5 to 14. And then the last one's down at the bottom. We want to write the formulas for these compounds. Easiest way to figure out which element it is you look at the beginning of the name. Chlorine or chloride comes from chlorine. Oxide is from oxygen. Fluoride is from fluorine. Sulfur or sulfide is from sulfur. And then this is oxygen again. So calcium chloride is from Ca2+, and chloride is Cl1-. So that's CaCl2. Sodium oxide is from Na1+, and the oxide is from oxygen, which is O2-. So that's Na2O. And then potassium fluoride is from K1+, and fluorine is F1-. So it's just KF. Magnesium sulfide, magnesium is 2+, and sulfur or sulfide is from sulfur, which is 2-. So that's just MgS. And aluminum oxide, aluminum is over here. So usually you're looking in group 1 or 2, but there are group 3 elements that form salts, especially boron and aluminum. So you have aluminum is Al3+, and the oxide is from oxygen, which is going to be O2-. So Al2O3, aluminum oxide. So these are the correct formulas for each of those compounds: calcium chloride, sodium oxide, potassium fluoride, magnesium sulfide, and aluminum oxide. Really, from now on in the course, anytime you see the name of a formula, you should be able to think of and write or find the name of an ionic compound. You should be able to identify that it's an ionic compound because it ends with "ide," and then you should be able to write the formula for it and do it pretty quickly. And then similarly, if you see a formula for a compound and you can identify that it's an ionic compound because it's made of a metal from the left-hand side of the periodic table, or at least from groups 1, 2, and 3, and then a non-metal from the right-hand side of the periodic table, you know that it's an ionic compound. You can write the name as an ionic compound with the "ide" ending. So, I mean, I kind of did those pretty quick because, I don't know, I've been writing these for a long time. I guess I started writing compound formulas back in like 1988, back in Mr. Larson's physical science class in middle school in 8th grade or something like that. Mr. Larson was a bomb. He was a pretty cool guy. So, I don't know. I do it pretty quick because it's pretty easy for me, and I work with these compounds a lot. I'm familiar with all of them in some kind of way, and that's what you need to do, is get familiar with them and be able to write them pretty quickly. You'll see how these ionic compounds differ from ionic compound naming with transition metals, because what we're going to do the rest of this week is figure out how ionic compound names and formulas work with transition metals. Transition metals are the metals in the D block, and partly they're called transition metals because it's like the transition from the S to the P, and there's little tricks to them. Like, there are different forms of iron. There's Fe2+, and there's also Fe3+. And because the transition metals can have different we call oxidation states, they can have different amounts of charge, and we have a way to write names and formulas so that you can identify whether it's iron 2 or iron 3. I'll show you that. Then we also have polyatomic ions, which are ions that are made of 2 or more individual elements. And the naming scheme is pretty similar, but it's a whole separate thing. Okay, I don't see any questions in the chat. So here's the deal. You need to do the Ionic formula writing and naming assignment. It should show up on the right-hand side of your upcoming for it, like, and it should say like upcoming for tomorrow, but you can do that right now. If you want to stay and you have questions or you're confused about anything or you want me to go over any more, I can do that. Otherwise, you can go and do that assignment. I'll see you back here, same time, same place, tomorrow morning at 8:30. Any other questions?